So let's talk about your 6.4 homework. So one of the questions on 6.4 homework is the one with the gondola. So it's very similar to the one that we gonna review. So I think you guys have the review for your test, right? This is a review for the test that you guys got. I think you guys did pick up a copy of this in your last Wednesday class. So we'll review this and we will talk about one of your homework questions, which is about the gondola light, ski gondola ones. So which is question number 11. It's 11 or 12? I think it's 11. Yeah, question 11. So not this one, not 11, sorry. Not 11. This is number, is that number 11 or 12? One of these questions. Not this one. Which question is it? Does anyone know what? This one. Sorry, number 7. Yep, number 7. So this question is talking about the ski gondola carries a skier atop the mountain, assuming that the skier is normally distributed with a mean of 184 pounds. Oh, too early. I'm gonna wait for a little bit. It's still not 4:30 yet. So this is the questions that someone asked me in the homework. I got a couple, 2, 3 students asked me this question. Because we still have time. Anyone have any questions for me in your online homework besides 6.4 question 7? Anyone have any homework questions for me? Besides this question number 7, which I know a few of you asked me these questions. So this question is where they ask us that it is a ski gondola with going up to the mountain. Weights, assuming the weight of skis are normally distributed with a mean of 184 and a standard deviation of 42. And the gondola has a capacity of 25 passengers, and it says it can go up to load limit of 3,500 pounds of a total rate load limit. So the first question is asking us is what is the maximum mean weight per passenger? So in order for us to find the maximum mean weight, we just take the total load limit over by the total number of people. So it's like an average. So so in this case that it is 3,500 and we divide by 25. So this is the maximum that one person can have. So if you divide this, you will get, that's your answer for the part A. So 140 pounds. So that means that in an average, the maximum mean weight per person, one person, is around 140 pounds. So when the question is asking for integer, as Casey mentioned that last time, integer means that whole numbers. Okay, so they should, I don't know why they should be whole numbers. So that means that when the question asks, the question wants you to enter as a whole number means you cannot have decimals. Okay, so that is the maximum weight. So now the question B is asking for if the gondola is filled with 25 randomly selected skiers, what is the probability mean weight will exceed from the value from part A? So part A means it will exceed 140 pounds. So in order for us to do question B, again, this one we have to use central limit theorem. The reason why we use central limit theorem for question 7B is because there are 25 people are picked. So once you have an n people picked, central limit theorem is used. The mean in this case is given us by 184. And the standard error in this case is 42 pounds over by square root of n. In this case is 25 people. And you need to figure out what is the probability. So this question is asking for probability that this exceed 140 pounds. So 140 is right here. And exceed means you shape to the right. This is the meaning when you're talking about exceed. So in order for us to figure out what is this, first thing first, you need to use your stack crunch. So we will use the stack crunch here. Where's my stack crunch? There you go. So for this case, you have to use so many windows pop. Minimize everything so we can see it. So we will use sorry about that. Stats, calculators, and normals because we're doing normal distribution. So the mean in this case is 184. And the standard error in this case, or standard deviation in this case, is 42 over by square root of 25. We know square root of 25 is 5 in this case. And you need to be exceed. So exceed is greater than 140 pounds. So you have to exceed 140 pounds. So you will find the probability in this case. And that probability is 0.9999992. So since this question wants us to round your answer into, I don't know how many decimal place, 4 decimal place, this answer is still going to be 1. What does that mean when your answer is 1? Means it's 100% that this ski gondola will have a will stuck. So this 1 stands for 100% that your gondola here will stuck, means it's not going to work. Okay, so if you want to go on to this ski gondola, you will not want to go it because 100% it will stuck in there. So instead of 25 people for this case, for question C, they make the new weight assumption. Instead of 20 people now is 20 people. So this 20 people, so we need to find what is the average weight. So if you remember last time, in order for us to find the average weight, you take the total weight over by the total number of people. So since the total weight is still 3,500, we will use 20 people. So now this weight is 175. So this question changed a little bit for question C here is because we are changing 20 people. So we are still using central limit theorem because there are only 20 people involved. So N is involved, so we have to use central limit theorem. We're still having 184 is the mean. Your standard error in this case is 42 over by square root of 20. This times we don't use 140 because 140 is for 25 people. So we will use 175. Okay. The reason why is because that is the mean weight per person if you make it to 20 people. And you're still looking for exceeding. So that means that you're still shading to your right. So this question, again, you need to use your stack crunch here. So we'll be doing mean is still 184. Your standard error now is 45 over by square root of 20. So this is how you put it into your stack crunch. In your standard deviation, or we call it standard error, is 45 over by SQRT 20, means is square root of 20, and you are exceeding 175 because that is the new mean for 20 people. This probability in this case is not 1, it's close to 1, it's 0.8310. Okay, last time is exactly 1. So that will be the probability for this case is 0.8310. So the last question in this case is asking is this 20 passengers safe in this case? Now, as you guys remember that what is this 0.831 that you found here? This is a probability that this is over by 175 pounds, means that this is probability that the gondola will not work. So in this case, in order for you to be safe, this probability has to be less than or equal to 5%. Always we use a 5% in this case. So what we do here is this probability is over 5%. So this is not safe. Okay, so we want to, in order to be safe, this number has to be smaller than less than 5%. So since the probability of overloading, here, is over 50%, so the new capacity in this case does not appear to be safe. Okay, so again, we will use 5% as our cutoff point. So so that's the reason why that this one is not safe at all. Okay, so we want to make this probability as low as you want, because that probability that you're looking for is what we call as overloading, or another meaning means the gondola will not work. When you overload, means it's stuck. So this is how we do this question on number 7, I believe. Yep, this is number 7 in 6.4 homework. Anyone have any questions for me on your online homework here?
Yep, Professor Liu. I have a question for number 6.
Yep. It's the similar type.
Yeah, my problem is how come the standard deviation is changing, but the mean is not changing?
This is from 6.4. We do central limit theorem. You missed my class on Wednesday. That's the reason why.
I'll talk to you after the class.
If you look at 6.4, it's talking about central limit theorem, and the central limit theorem says that the mean is going to be the same, but the standard deviation or standard error is sigma over by square root of n. Right here. Yep, that is the meaning of it. So if you have one person, you don't use central limit theorem. If you have more than one person, you're required to use central limit theorem. And that's why your standard deviation or standard error in this case has to be standard deviation over by square root of n. That's the formula we are using. And okay. This is 6.4.
Yeah, thank you.
Yep. So class, if you miss my class, make sure you let me know or send me something else, because you have to actually brush up all this on your own, unfortunately, if you miss my class. So this is very important. My question is that my proposal is don't miss my class, because that is big stuff. If you miss my class, you have to really brush this on your own, or watch some YouTube or something else on your own. Okay. Anyone have any? So do you know how to do question number 6 now?
I do. I think I do.
So let's do it together, because this is, again, is a good practice for your test.
Yeah.
So then elevator says that you got 10 passenger or maximum capacity of 1,710 pounds. So if 10 mils is to be set on this passenger, is 1,710 over 10. So that means that the elevator will be overload. That means no good. If the probability is you want to find is greater than 171 pounds. Okay, and the mean is 176 pounds, and the standard deviation is 34 pounds. So what happens here is we will be using central limit theorem. The reason why we are using central limit theorem here is because there are 10 people involved in this case. So central limit theorem is used. The mean for this case is 176, which is the same mean, but your standard deviation or standard error in this case is 10 over by square root of, not 10, sorry, 34, because that's a solution, over by square root of 10. And you want it to be greater than 171 pounds. So 171 is somewhere here. Greater means is this, means this is again overweight or overloaded, or your lift will not work. So go ahead, take out your stack crunch and figure out what is this probability is. And we'll do question 8. You guys have to do it. That's the reason why I will do a little bit of stuff, and then you guys have to figure out your own here. So like this, I will call you to do it your own. So this is very similar to what we did just now. Go ahead and use your stack crunch and do number 6 here, question 6. Anyone? Grace, Casey?
Sorry, I actually wasn't listening.
So the mean in this case is 176. Nadia, what is your standard error in this case, or standard deviation?
Is it the 171?
No, that's not your stat. Where do I usually write if I put it on a, where is the standard error or standard deviation if you see it on the picture here? Where was it at? These are your standard deviation that I put.
It's 184, or sorry, it's 42 over
34.
square.
34 over by
Oh, we're doing 6? Yeah, 34 over square root of 10.
10, right?
Yeah.
So you have to type 34 over by SQRT 10.
So, Prof,
Lawrence?
what if I decide to put like just type my calculator and put the number in that standard deviation? Would that work?
Nope.
It
If you
won't
want to
work?
type, if you want to write, you have to write all the decimals.
Oh, okay.
So you cannot round it.
Maybe that's why I'm getting it wrong.
That's why you get it wrong. That's why right here, you see what I'm typing here? I do not want you to put, so when you take 34 over by square root of 34 divided by square root of 10 is what? This number, right? You have to type every single digits in there. You cannot round it. If you round it to 3.2, you get everything wrong. So
yeah, it's giving me 0.9999.
Yeah. So to fix this, what do? I don't type 3.162. You have to type the whole thing. You have to type 34 over by square root of 10 in your standard deviation here. You see that?
Write it down, please.
Yep. So you have to type it in. SQRT in here means square root.
Okay, SQRT, okay.
So it's 34 over by SQRT 10. And if you want to find it over 171, so that's 171, and you hit compute.
So it's going to be SQRT 10, right?
Well, whatever you have in your number, in the square root.
Yeah, I got what you mean.
And you
Okay.
need to put parentheses around it.
Around the 10? Okay, okay, thank you.
Yep. So that will be your answer. So please don't use this number. You have to use this. So your answer is 67.904889. Now this is where you guys will say your answer will be wrong in your homework. Is if you write this is what 3 point. What do you do, Lawrence? You put this as 3.2. So if you use 3.2 here, you didn't use the whole thing. Your answer will be big
Yeah,
different.
yeah, exactly. I go 0.9 here.
So you actually have, yeah, for us, 3.2 and 3.16 is a big difference. So you do need to, yes, that is called rounding errors, remember?
Yeah, yeah, that's
When I
yeah.
This
was
still,
doing my
wow.
homework, I round to 4th place, and he took it.
No, this is still wrong, 3.1622. So I would recommend you guys, yeah, this answer you had to round in 4 places, but this, do not type this, just do what? 34 over by square root of 10. This is a safe to do, Lawrence.
Yeah.
Same thing in your test, okay?
Thank you.
And round this into 4 decimal place is what? 0.69. Is that 34, not 31. Sorry, this is wrong. 34. So 67. What's the 4 decimal place rounding here?
90.
So it's 6790.6790 in this case. And then this is the same thing. Is that elevator to be safe? Since again, this is not less than 5%, so this elevator is not safe. Okay, so no, 10 rents will never be so the answer will be no. This will not no. That's a good chance that the 10 renters adults meal will exceed this. So the chances of this, if you're stuck on the elevator, is almost 68% stuck. You do not want to be in the elevator in this case.
So, Prof, have you posted all the class online, like all the sheets of paper that you can print out?
Again, because our Wednesday class is a face-to-face class, I have no one else to record this. You know what I'm saying?
Yeah.
So I for all the Wednesday class, it's not Zoom. There's no Zoom, so that's why I cannot record what I'm teaching.
Okay.
So you do actually need to watch my last semester class. All right, Nadia, you asked me this question, right? So you guys have to do this. Yep, Nadia. Number 8. So what do we do with question 8 here? Now, are we using central limit theorem on this case?
We can see the okay.
It's a kind of very similar to your number 8. The number's a bit different. So Nadia, how do you do question?
I tried to do it, but I was not even able. It's confusing a little bit.
So can you draw me a picture? What is this talking about? Nadia?
Yeah, give me a sec.
Are we using central limit theorem here?
I have a question about this one.
Mm-hmm.
Can we just plug this into StatCrunch where we do the mean of 14.6 and the standard of 0.9?
Mm-hmm.
Okay.
But in your test, I do want you to draw the picture. That's why I want you to draw the picture.
But if we put it into StatCrunch and the picture pops up, then we can just copy the picture, right?
It's up, yep.
Okay, good.
For me, is you need to know what the picture looks like. So
Yeah. I mean, if you draw it and you're doing the mean, so where that central line is, it's 14.6. And then the standard deviation, which is above it, is going to be 0.9. So it says, find the probability that if an individual man is randomly selected, his hip breadth will be greater than 16.9. So then you find the 16.9 and then you shade to the right because it's greater than.
thank you, Casey. Nadia, you got it?
Yeah, I got it.
So how do you put it in your StatCrunch?
Is that like the normal distribution?
Mm-hmm.
And then right there you put the 14.6 on the mean,
Mm-hmm.
and then on the stats deviation you put the 0.9,
Mm-hmm.
and the
Mm-hmm.
actually I can't see the other numbers. But is it the
16.9.
16.9? You put it right,
The first or the second
right,
bar?
the second one.
This
I
one?
mean the first one.
This one?
Yeah,
This one?
I think so.
And then are we using greater or less than?
Greater.
Does this picture looks like the picture I draw?
Yeah.
Then it's correct then. That was how you do this question. So the answer is this. Do we using central limit theorem here, class? Are we using central limit
No.
theorem?
No,
No,
No. Why we don't use central limit theorem here?
because it's one person.
Very
Yeah.
good, because it's only one person. We're talking about one person here. Now do B.
this one you got to add the 130 people in there.
So central limit theorem here.
Yep.
So you need to know the difference between when we use central limit theorem and when we don't. So the mean is still going to be 114.6. But what happens to your standard error, standard deviation?
It changes.
To what? From this to what?
Well, you're going to have to put in 0.9 divided by square root of 130.
Yep. So this is a different, this is what central limit theorem do is the mean is the same, the standard error will be standard deviation over by the square root of n. And where do we need to shade here?
On the left.
Greater than 16.9.
Right.
So it's 16.9 and greater. So it's very similar to part A that you have. The only difference here is your standard deviation or standard error here is going to be this.
I have a question.
Mhm.
Where do you get the 130 from?
From your question.
Okay, got it.
Asking for 130 here. I don't know y'all, but minus 130. So what happens to your R here? What happens to your StatCrunch?
You have
Everything's
to
the-
change
Which one you need to change?
the standard deviation.
Is what? 0.9 and what else?
Divide by square root of 130,
Yes,
and the
that's
rest
it.
is
Mm-hmm. Very good. And this came out to be what?
is that 0?
0. What 0 stands for? Zero chance, 0%. It will not happen. So when you talk about seat design, are you looking at part A or part B? So part A means 1 person, part B means 130 person. So when you sit,
No, it's part A.
when
Wouldn't
you
it be-
when you sit on your chair, how many people sit in your chair here? Only 1 person sit or 130 people sit in the chair?
1 person.
Only 1 person. So in this case, part A is the one that we do here. The reason why it's part A is because there's only can only by individual 1 person. So this kind of questions is a lot when you do 6.4. If they do 1 person and then they do like 130%, then you have to figure out which is more important. Like the elevator that we did in question 6 here, the 10 people is more important than 1 person, the other way around, because when you're in the elevator, 1 person, the elevator will be work no matter what, right? But if you got 10 people, then you might scared, you might stop. So if a question is asking you to find 1 person and asking to find 10 person, then they'll ask which one is more, which one do you use? We're gonna use 10 people here because that is the main part of this case. Because there are 10 people in the elevator. Same thing with the gondola here. We are looking for also a group of people and people, not 1 person. Because if 1 person in the ski gondola, the thing will work no matter, you're not worried. But if there are 20 people in there, you kind of worried about it, right? Because it might not work in this case.
Do we have a question on the test that asks similar questions to part A, where we have to divide 3,500?
Oh yeah, yes. You mean standard, because central limit theorem? Yes.
No, maximum.
Oh, no.
Okay.
No, not this one. No, I will give you this number, the 140. I will give you this number. So, not 8. Any questions for me? Next, how do you review for your test? Let's say you want to go back to your old questions. You go under grade book here. So if you click grade book, in your StatCrunch, that is all the review. So this is how you review format. Let's say you need to practice binomial. You can go into under grade book, go under any sections you want, click the review sections, and you can review as much as you can here. Okay, so some of you want to review for your test for Wednesday. So go hit grade book and then hit review, and that's all the sections where you have here.
It doesn't go as far back to chapter 1.
You just need to say all assignments.
Because I did, but
entire course to date, not past 2 weeks. So the whole course. So you have to change to entire course to date. Then you will get the whole thing.
Professor David, Professor Liu, yeah. Now, in the exam, right, how do you differentiate between question, if you want to use start crunch, right? If you're going to use binomial or random or, distribution, how do you differentiate?
Very good. So let's take a look at your review here. So how do we differentiate between using a binomial and a normal distribution, so on? So I will tell you straight, this is a very good question. If you read the questions, if I have a normal distribution, it will have the word what? Normally distributed. So if this is not, if they have the word normally distributed, then you use normal distribution. Okay. How do we know it is a binomial? A binomial, you have the word number of. So because it is a discrete case, so if you see the number of, this will be chapter 5. Okay. This is also a number of, because we're talking about adults. So adults means you can have 0, 1, 2, 3, 4. So this is so it's a discrete case. So this will consider as binomial. Okay. And binomial needs to be how many outcomes? 2 outcomes. So you have to look at it and figure out. So this is how we figure out if they are normally distributed, they are binomial distribution, or we got one more called uniformly distributed, which is also written down in the test. Use the word uniform distributed. So in other words, you have to read the question really carefully, figure out that if you see the word normally or normally distributed, automatically that is chapter 6. Okay. And if you see like number of, that means the number that we're talking about here is either 0, 1, 2, 3, 4, 5, means it's whole number. You cannot have decimals. Then it is chapter 5. Okay. So that's how you figure it out.
When it's uniformly distributed, is it uniformly distributed? It is chapter 5,
So,
right?
if you have uniformly distributed, then in your you have to use a uniform calculator. So you go to stat calculators and you go uniform.
Okay.
If it's a binomial, you go under binomial.
Okay.
If it's a normal, we go under normal.
Okay. Thank you. Thank you. That's very important. Thank you.
Yep.
Is there any way we can go like through a couple of these?
Yep.
Because can you look at number 16? Because I'm drawing a blank on this. I feel like, am I missing some kind of like more information?
So how do we do number 16 here?
16.
So it says that the Newport Light and Company has a electricity has a voltage that is uniformly distributed between 123 and 125. So the graph that you draw here is not a bell shape, it's a uniform shape.
Yep.
And you start at 123 and it ends at 125. That's what it says. That means this is your minimum, this is your maximum. So you have to draw a graph based on this. So this is the graph looks like. And then in part A, so part B, you have to figure out that this is what? Greater than 1, 2, 3. So 123.5 is here.
I get it.
Greater means is on the other side.
Okay.
And
I got it now.
you cannot use this because this is normal. You have to use the uniform one.
Yeah, I did that and I think it threw me off because I'm so used to, you know, like saying the max and the minimum, but I'm seeing it as between 123 and 125. So I didn't see it as the lower limit and upper limit. Okay.
Yep. So usually the question in the beginning, they will give you the mean and max. And then if the question asks you to find the probability, this is where you put in the second line.
Okay. And then this, do you want us to draw you the shape? I mean, like the thing too, or no?
If the question asks you, yes. So the shape will look, for 16B1 looks something like this, the graph.
Okay.
And then you put 123, 125, and this is greater than 123.5. So you just change 123.5 here. And so make sure in your test, if I ask you for the graph, make sure you draw the graph. And then the last row, I want you to write. So don't give me this in your test. You have to give me Px greater than or equals to 123.5 is equals to 0.75. So 0.75 is your answer. But in the test, this worth, if it's an open-ended question, this worth 3 points. 1 point for the picture, 1 point for the P, and then 1 point for your answer.
Okay.
Would you want pictures for every part of the question?
That's why I'm drawing pictures every time. You see, I draw pictures every time.
Yeah, but like for A and for B. you would want a separate picture
Yep.
because it says like
Mhm.
greater than, yes,
Yep.
okay.
And then B2, you had to draw another separate picture. And then B3, you had to draw another separate picture.
Okay,
Because the pictures are all different here. They're not the same as this.
Can we do 7, please?
Number what?
Number 7.
Number 7. Okay, we're gonna go back to so let's go on back to the first, because this is the first few one is the one that a lot of students we'll do number 6. Does anyone know how to build a table in this case?
Yeah, I don't remember this.
Will be in your test.
No.
So a data below shows 24 nicotine amount in a non-filter king size cigarettes. You have to construct a frequency distribution beginning with a lower class limit of 1.0 and a class width of 0.2 milligrams. So you have to draw a frequency distribution. So how do you build a frequency distribution?
So is this the one where you like, you know what threw me off with this one? It talks about the class width of 0.20, and then it's got like the 24 nicotine amounts. I think there's like way too many information.
So what is going on is that you start with a lower class of 1.0. So the next one is a class width of 0.2. So you need to add 0.2 to 1.0. So if you add 1.0 and 0.2, you get 1.2. Where should we put 1.2? Should we put it underneath or across it?
under.
Across it.
Okay. Don't forget, what is the definitions of class width?
Difference between lower.
The 2 consecutive lower. Yes, correct. Suli, that was correct. So this is the correct way. So if you go across it, this is wrong. And do you know what happens if this is wrong? Everything you do is all gonna be wrong. So make sure you go under it. So you have to keep on adding 0.2. So this is 1.4, 1.6. And what is the highest it goes? If you look at your data, the highest is what?
1.8.
1.8. And you stop. You don't continue doing 2.0, 2.2. This is no good. Okay. So make sure you stop at where is the highest one. If a highest is 2.1, then you have to continue working on. So this is what we call as the lower class limit. Can someone tell me what will be your upper class limits here? So what number is less than 1.2?
1.1.
Well, 1.
Now, some students give me 1.19. Can you do 1.19, which is still less than 1.2, right? Can you do this? The answer is no.
No.
The reason why you cannot do this is because your data only have 1 decimal place. Okay. So since your data has 1 decimal place, this one has how many decimal place? 2 decimal place. You cannot do that. So make sure that don't put 9 behind, because you have to match with him. What's the next one after 1.1? 1.3.
1.5. 1.7. 1.9.
Yep, and that's it. And the next you need to do is frequency. So you have to count how many of this data falls between 1.0 and 1.1. So you have to count it. 1, 2, 3, 4, 5. Yep, you have to count it. So there are, I think it's 13 here, right? So you have to count them.
Oh, okay.
And then how many of this data is 1.2 and 1.3? I think it's 3 or 4 here. How many of this is between 1.4 and 1.5? There are 3 in here, and then 3, and then 1. So you actually have to count it. But in my test, this data is being sorted for you. What I mean by the data is being sorted means that it goes from low to high. So that means that counting for you is very easy. You just, you go from, so it's go from smallest to the highest number. So you do not need to really count it. You just, really like, look at every single, it saves you time actually. So this is what we call as what? Frequency distribution. It's called frequency distribution. And the question is asking, once you finish drawing a frequency distribution, the question is asking for midpoint. So does anyone know how to figure out midpoints here? And the boundaries. We'll do midpoint first. Anyone know how to find midpoints? Midpoints? Nadia?
Are we not supposed to do it with the stats crunch, like crush whatever?
No.
And then, no,
Mm-mm.
never
No
mind.
stat crunch on this question 6. Midpoint. Anyone know what midpoint stands for? Class midpoints.
It's 1.05.
Yes. So class midpoint means it's the average between the class. So what you do is you add them up and divide it by 2. So this class midpoint is 1.05. You're correct, Suli. And what is the class midpoint for this one? The next one. So again, add up and divide by 2, you get what?
1.25.
And then you repeat again. For this one is 1.45. And then 1.65. And then 1.85. So this is called class midpoint, the one in blue. And if you look at your class midpoint, what is the difference? Same as what? Your class width, which is 0.2. Now, does anyone know how to find your class boundaries? Anyone?
So you take the upper one plus lower one.
Yep. So you go upper and the upper of the first and the lower of the second, and you do the average. So again, you add them up. So green one you see, you add them up and divide it by 2. So what is 1.1 plus 1.2 divided by 2?
1.15.
And you repeat the same thing, 1.3 and 1.4, which will give you what? 1.35. 1.5 and 1.6 will give you 1.55. 1.7 and 1.8 is the next one. You get 1.75. Is this all the class boundaries you have?
No.
No. So where else do we have a class boundary?
The upper one and the lower one.
Very good. That's correct, Suli. So in order for you to have boundary, class boundary, you need to do an additional upper and additional lower and upper. But if you look at the pattern, again, what do you notice on this pattern? They all have a difference of what?
0.2.
0.2. So if you want to go for the next one, you just add 0.2, which is 1.95. And if you want the one before one, you just subtract 0.2. Does anyone know what is 1.15 minus 0.2? .95. So what I want to point out to you guys here is you got 5 classes here and you will have 6 boundaries. You always have one extra more. So that means you will still have 5 midpoints. So 5 classes, 5 midpoint, 6 boundaries. So you got one more extra in this case. So this is your class boundary in this case. Questions?
Prof, so how did you get this 0.95?
You subtract 0.2. Or if you want, you can figure out what is this number. Anyone know what is this number above here? Look at pattern 19, 17, 15, 13, 11. 0.9, right? So what is the middle point of 0.9 and 1.0? 0.95. That's how we figure out this number. Or you keep on adding or subtracting 0.2 because your class width is 0.2. The last two ones, relative frequency. What is the meaning when I want you to find the relative frequency? What is relative frequency?
You continue to add, like the first one is going to be 13.
That is called cumulative.
So I just count how many people are between 1.0 to 1.1.
Relative frequency means you have to change your frequency to become percentage. So what you do is you add all your frequency here. How many people do we have here? We got, how many nicotines we have? We got 24, right? So how do you find the relative frequency for the first one? Is you take 13, which is the number, over by what?
24
times
100.
100. Same thing on next one, 4, because you got 4 here, over by 24 times 100. And you do the same on the rest of 3, 3, 3, and 1 over 24. So this is called relative frequency distribution. Questions? What
Will
is the
Will you tell us how many to round to?
It's again, if I didn't stated how many decimal place, 2 or 3 decimals.
Okay.
Where it's, yeah, until if I say 4, until the question mentioned I need 4 decimal place, then it's 4. But if I didn't say anything, 2 or 3 is good for.
We
Now-
wouldn't get wrong if we put the whole decimal, right?
What do you mean by whole decimal?
Like if we don't like, so you said if you don't ask us, we should put like 3 to 4.
2 or 3 decimals.
Yeah, so if we instead, like let's say we write the whole thing that the computer, like the calculator give us, are you gonna take points for that?
What do you mean by that? So if, let's say, if you do this, 4 out of 24 over 100, you will get what? This one, right?
Yeah.
So you give me, what's your answer here?
16.666.
16.67.
Oh, we rounded up. Okay.
Normal rounding. Next, cumulative. Class, this is not, rounding is not my class. You should know how to round. If you doesn't know how to round, then you are not in my class. You are in like algebra 0. That's where I teach you rounding. Rounding is something you should know already when you come to my class. Next, we talk about cumulative. What is the meaning of the word cumulative frequency distribution? Means you accumulate. So that's where Lawrence says correct. So you have to add. But the first one we have is just what? How many frequency? We only get 13. The next one you have to accumulate. So that means you have to add. Yes, Lawrence?
17.
That will be 17. So you add, and then the next one you add all that class with the previous classes. So you get how many? 20. And then the next one is 13 plus 4 plus 3 plus 3. This is 23. And then the next one is you add everything, which is 24. So this is what we call as a cumulative frequency distribution, where you cumulate. You do not change them to percent. Let me repeat. I got some students change this to percent. No, just leave it as these numbers. However, this cumulative frequency is not using the same numbers here. These are not the same number for cumulative frequency, because in cumulative frequencies, you cumulate from the lower end. So the first one is actually the nicotine is from 1.0 to 1.1. The 17 that you say that you add is you adding 13 and 4. So the cumulative here is actually goes from 1.0 to 1.3, because this one goes from 1.0 to 1.3. The next one is where you add 13, 4, and 3. It accumulate from 1.0 to 1.5. And then the next one is 1.0 to 1.7. And the last one is 1.0 to 1.9, because it accumulates from the end to the first. So this is called the cumulative frequency distribution. Okay, so a lot of students forget to write this down and they will take points off. I will take points off. So be careful with this. And the last question on this 6, this is all question 6. This is going to be in your test. Does your distribution appear to be normal? So what is considered normal? Anyone? What is considered normal?
The bell shape?
Bell shape, Grace, that's good. So you are looking at your frequency. And if you want to have bell shape, you can kind of draw it out on the histogram. So as you know, normal means like a bell shape, right? Like what you just did in chapter 6. So the first one you have is 13. So 13 is way up here. This is 13. And then the next one is 4. And then the next one is 3. And then the next one is 3. And then the last one is 1, right? Is this bell normal?
Nope.
This is not normal. Okay. So in order for us to have normal, this frequency has to go from low to high to low, and it has to be symmetrical. And you can tell this number doesn't go from low, high, low. So the best way for you, if you doesn't know about this, just draw this, take all this frequency and draw what we call as a histogram. This is a histogram, and figure out, does it looks like a normal curve, like what we did in chapter 6? Because normal curve is low, high, low, and then it's symmetrical. Okay, so this is not normal distributed. Questions on this? This is all question 6. If you want to practice this, I would recommend you to do 2.1 in your online homework. So go to your 2.1 online homework and practice, because this is in 2.1. Okay. Question 7, 8, 9. This question 7, 8, 9, you have to use this histogram. So the question is asking for how many, this is histogram is showing you that how many cars are there that weigh between 25 to 4,500 pounds. So the question is asking us is how many cars do we have in this histogram? So like here, how many nicotines we have? So we just need to take all this count and we add them. So same thing here, you just need to figure out what are your frequency here, and then you add them. So the first one we have is, this is 1, right? This one is what? 3. This one is 2. This one is 4. This one is 3. This one is 4. This one is 3. This one is 5. This one is 6. And this is 1. Right? They all have frequency here. So what you need to do here is, in order for us to answer how many cars in this histogram, you just take your calculator up, and what you do, add them up. So that is how you figure out how many cars in the histogram. Anyone? Calculators?
32.
Okay, there are 32 cars. And then the question also asks, how many cars weighted more than 4,100 pounds? So where is 4,100 pounds in your histogram? Anyone? Right over here, right? This is 4,000. So 4,100 is right here, right? And what's the meaning when I say more than? Where do we shade?
To the right.
So how many cars is more than 4,100 pounds?
7.
7. 6 plus 1, right? This and this. What is the class width? How do you find class width here, class? Class width is from here to here. Can someone tell me if this is 2,500? What is this one is? The one next to him, this line.
Wouldn't that be like 27.5?
So how do we know if it's 27.5 or 27 or something else? So we have a formula to figure out class width. So in order for us to figure out class width, what you need to do here is you just need to take the maximum and the minimum, you subtract it. So you take maximum minus the minimum, and you divide it by how many bars we have. So what is the maximum? Maximum is 4,500. What is minimum? Minimum is 2,500. How many bars we have from here to there? How many bars?
10.
10. Yep, that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 bars. So can someone use a calculator to figure out what is 4,500, subtract 2,500, your max, minus your mean. Yeah, right there. That is 200. So what is this 200 means? It means that from one end to another end, the width is 200. So if you want to put in down what number is this number is 2,700. And then the next one is 29. This is 2,900. And how do we know that? It's because our class width is 200. And then the question 8, what are the lower and upper class limit of the first class? So your first class means your first bar. So what is a lower? The lower is 2,500 and the upper is 27. So first class means first bar in your histogram. So for that case, your answer will be 25 to 2,700. So this is your first class lower and upper class limit. Now I'm going to do a bit more, the 9 and 10. Now I will do something more important because what is more important here is number 12. This is so important that the test, this is worth a lot of points in your test. So we're going to do number 12 together. This is really important. Question number 12. What's the meaning when I want you to refer to Oscar data set? How do you get this in your StatCrunch? How do you get this in your StatCrunch?
You have to go into your StatCrunch and look for the Oscars.
So can you look through from the StatCrunch here? Can you do it from here? The answer is no. So where can you find Oscar data set? Anyone? Not from here. So look at here, you won't get it. You have to go under your homework.
It says,
It is
doesn't it say web step crunch?
You have to click on the stack crunch and where you go. Data set from your textbook.
Mhm.
This is where you click. And which one you need to pick?
actress and
Oscar winner H, right?
Mhm.
Click on it. And the stack crunch will open and you got, this is how we do this. And which one are we concentrate on if you look at my review? The actress or the actors?
actress.
Actress, right? So usually I will tell you which one to concentrate. So we are doing actress here. So make sure you have in your stack crunch, you have your actress in this case. Okay. So we are looking at actress. Where's my stack crunch? There you go. And the question wants you to find the mean, the median, the mode, the mid-range, and so on, so on, so on. So how do you do this? You go to stats, you go to
Summary stats.
and
Yeah.
column, and you select which one?
Actress.
Actress. And here, if you want to select all of them, you click on your mouse and you hit Control A. So I repeat again, you select actress on your mouse, you click on anyone you want, and you hit Control A. Control A in your keyboard means Control All, means you select everything. And you hit compute. This is everything that you see. So what is the first question they want you to find? They want you to find the
Mean.
mean. So what is the mean here?
13. Oh, no.
36.2,
2.
right? 242. I'm not picky with decimal places. I'm picky. I need to know how you do this. What's the next one they want you to find? Median, right? And what is your median here?
33.
Median is 33. What's the next one they want you to find?
Mode.
And what's mode here?
29.
29. Next one,
Mid-range.
mid-range. Do you see mid-range? No, there's no mid-range here. Does anyone remember what is the formula for mid-range?
Q3 minus Q1.
That's not mid-range. What was that? What is Q3 minus Q1? What we call that?
Interquartile range.
Interquartile range. Yes, not the same thing as mid-range.
Minimum plus max over 2.
Yes, it's minimum plus maximum divided by 2. What is the minimum and what's the maximum here? Minimum is 21. What's maximum? 80. This is min and max divided by 2. Anyone got an answer here?
50.5.
Yep, that is correct, Grace. What's the next one? Can someone, I don't want to go back to review. Anyone, what's the next one I want you to find after mid-range?
The range.
The range. What is the range in this case? Within the question, in this C range, 59. That's a range, 59. What's the next thing?
Standard deviation.
Standard deviation. You can shortcut in SD. Yes, you can use that in the test. What's standard deviation here?
11.4. Where is it?
11.47. What's the next one after standard deviation? Variance, right? 131 point something. 131.49. What's after variance?
Q1.
Q1. This is all in here, right? In your review, right? I'm just going over. And what is Q1 in this case?
29.
Q1 is 29 and Q3 is the next one, right?
Yeah.
And what is Q3?
41.
Q3 is 41. And what's the next one? P17 and P90, right? Those are the last two left, right? So but if you look at there's no P17, there's no P90 here. So how do you find P17 and P19?
You go back and plug it in.
How do you go back?
You X out of this.
You do not X out of it. You go
You
under.
have to figure out your medium and then your standard deviation, and then you have to plug it into.
Nope, Casey, that's
No?
wrong.
Oh,
What P17 and P90 stands for is 17 and 90th percentile.
yeah.
So it's not what Casey says. So your stack crunch can do it, right? So you go back to your option, you go to edit, and where do you enter is right underneath this box. You see the percentile?
Oh, yeah, yeah.
So what number you need to put in? 17, 90. So that is for what? 17 percentile and what? 90 percentile. And if you compute, this will be a new box where they add what? 2 more numbers behind. And that is your 17 percentile, which is what?
27.
27. And 90 percentile is what?
54.
54. Now, if you do this in your test, you will lose 1 point. Do you know why you will miss a point here? Everything is correct. The reason why you lose a point is because you forget your unit. Yes, Austin, very good. And what is the unit in this case?
Years.
Years. Years old or years. So make sure you know that why you lose a point here is not because you get it wrong. Everything is right. Make sure you have what? The units. I really want you guys. Yep.
You said something like, we don't have to put like years on all of them. We can just write it down.
Do like what I just did here. Yep. Just
Okay.
put unit equals to years. You do not need to put years and years and years and years like that. You're correct, Casey. Are we done with question 12? Nope. This is just until. Next, you have to construct and interpret your modified box plot. Do you guys know how to build box plot, modified box plot in your stack crunch? We can X this one out now because we don't need him anymore. Do you know how to build modified box plot? Go to your graph and go what? Click on box plot. We want actress, right? Oh, no. Oh, there you go. I want him, so I want her, actresses. And if you want, make sure you draw the boxes horizontal, if you want to. Otherwise, they draw it vertical. In my test, I didn't care. Okay, so you hit compute. So this is your box plot. So what you do is copy and paste. How many dots do we have there? So you just draw like this, like this, like this, like this. And we got 6 dots. 1, 2, 3, 4, 6, something like that. Again, you do not need to be perfect. Something like what I just draw here will be nice. I'm looking more on these 6 dots, and I'm looking more, it's kind of, what kind of distribution we call this class? Skew to the
Right.
right. Now make sure that it looks like skew to the right, not symmetrical, not skew to the left. So we got.
Sorry, are we gonna have more space
Oh yeah,
for this?
yeah. This is
Okay,
definitely you got a whole page to do it.
okay.
This is the reason I want to review is because I want to squeeze everything into So so the next thing is, do you know how to interpret? This is very important. So does anyone know how to interpret your box plot? This is so important that I need to. Do you guys know how to interpret this? What's the meaning when I say interpret?
So with your CV or medium?
CV, DO, right?
Yes.
Absolutely, that's correct. What happens if your box plot has no outliers? Which one you interpret?
Just the CVD.
Yeah, C is which one?
Medium.
The mean. Yep. So no outliers. The C will be, you have to choose the mean. And the V, you have to choose what?
Range.
Standard deviation. So if there's no outliers, the C and the V is mean and standard deviation. What happens if there is outliers?
We do all of them.
No. Which one of this is not sensitive to outliers?
Max. Oh,
Max is sensitive to outliers.
yeah.
So which one of this is not sensitive? That's why we pick him.
Medium.
Median, is that correct? And which one is the IQR?
Mm-hmm.
This is very important. So when you interpret your CVDO, make sure you interpret this case. So my question to you is, do we have any outliers in this box plot? Do we have outliers in this box plot?
Yes.
Yes.
Yes, we do. So we should interpret. So we are using this one. So don't give me median and all these things. You have to write this in the full sentence. So the median is what? What is the median here? All these numbers. Where's the median?
33.
33. And the IQR. Now, the question doesn't ask for IQR, but can you figure out the IQR here, class? What's IQR stands for?
Q3 minus Q1.
Yep, Q3 minus Q1. So what is the difference here?
41 minus 29.
Which is 12, right?
Mhm.
So this is how you take care of your C and your V. D stands for distribution. So what kind of distribution we call this?
Skew to the right.
So make sure you type it out, write it out. The distribution is skewed to the right. And O stands for what?
Outlier.
Outlier. So how many outliers do we have here?
6.
Now, a lot of students make this mistake because they count here. Oh, there are 6 dots. So 6 outliers. But if you highlight this, how many outliers do we have? We have 7. The reason why is because they are 2 numbers are the same. So if you look at this, 60, I think, let me see what number, 63, 60, 74, 61. 61 is the one that has how many? 2, but they only have 1 dot because they are the same dot. So in this case, they are not having 6 outliers. They are having how many outliers? They are having 7. So be careful with the box plot. Doesn't mean that if you see 6 dots, you have 6 outliers. You can have more than 6 because if they share the same number, the box plot only represent by 1 dot. So make sure you highlight it. So make sure you just get your mouse and then draw a box on it, and they will highlight this and they will tell you how many there. And this is showing 7. You guys doing okay here? Are we done with question 12? No, not yet, because that is just construct and interpret.
Wait, I have a question. So all that you were writing down, like what the mean or the median is and IQR and all that stuff, you want us to write it like that?
Yeah, you mean the interpretation?
Yeah, where you
Yes.
said the median is 33 and the IQR is 12 and
This, yes, this is how you're gonna
Okay.
write in your test.
okay.
Not like this. Mm-mm. You will write in full sentences.
Okay.
And the last thing we're gonna talk about here is an actress who was 80 years old considered significantly hot? Still question 12. This is all question 12. So question 12 in your test looks something like this, and it's worth like 20 points. Because you have to do a lot of work here. So is the actress who is 80 years old considered significantly high? So how do we know if it's a significantly high? Either you use what? ROROT, or you find the z-score. Because we got the mean, right? We got the standard deviation. We got all the goodies in here, all the statistics. So now I'm gonna pick z-score because in the test I will ask you to find z-score. So can someone tell me how you find a z-score for an 80-year-old winning actress? Anyone know the formula?
Mean plus.
Not the mean, that's RRT. Z-score formula is the value minus the mean over by what? Standard deviation. So this is an 80-year-old actress, so the value is 80. Where's the mean in this case? The mean is what? 36.24, which you calculate early on using your StatCrunch. What's the standard deviation here? 11.47. That's the standard deviation, 11.47. So use your calculator and figure this one out. That's what we call as your z-score. Make sure you have a calculator in your test. No cell phone. Any kind of calculator you can use, but not your cell phone type. I also will take your attendance, so please type present in your chat room. So this
3.82.
3.82, yep. So my question is this considered significantly high?
No.
What z-score is considered significantly high? Remember, I told you when you do ROROT, can you tell me what number that is cut off here? Anyone know what number is this to?
+2, -2.
So between -2 and 2, right? And this means this is significantly high, right? So what considers significantly high? Your z-score has to be what? Above what?
2,
Above 2. So what is the z-score you calculate for this is what?
3.815.
Right here. So is that significantly high?
Yeah.
So this question is yes. This is significantly high because this number, the z-score that you found, is what? Greater than 2. So that's why it is significantly high. So this is the end of question 12. I think this question in your test worth like 20 points. So if you want to,
I'm just wondering, I thought we could use either R or R.
yep. But in the test, I will ask you for a z-score.
Okay.
That's why I'm using the z-score. Yes, you can use the RRT in this case, but in the test we use it. I will ask for z-score. That's why I'm concentrating on z-score in this case. You can use RRT, but Again, my test is using this score. Questions? So this is actress, right? So if you want to practice, you practice with what? Actors. So if you guys want to practice this, because we just only concentrate on actress, so we try to use actors now. Repeat the same thing, the same questions, just repeat, change the actress to become actors and doing the same thing. Now, I will do one more questions and then the rest we will have review. So I need to figure out what time on Wednesday I have. So Wednesday I will have a review in the class at 4 o'clock because the test starts at 4:30, right? So I will be in the classroom at 4 o'clock and we will go over number 13. I will go over 13 together right now. So we go over 14 and 15 and the rest of it on tomorrow, on Wednesday at 4 o'clock in BHCC 108. So make sure you come 30 minutes early if you want to review. So we're gonna continue with the last question, number 13, before we end the Zoom here. So I will save this one. So the last one that we're gonna talk about here is number 13. So number 13 is asking us to, it's a bell-shaped, IQ score is a bell-shaped distributed with the mean of 100 and the standard deviation of 15. You have to fill in this table. Does anyone know how to fill in this table?
Yeah, so the main line is 100.
So right in the middle is a mean, which is 100.
Yeah,
And then?
well, to the right, you add 15 to each. So it's
you get
115,
115 followed
yeah,
by what?
130, and then 145.
So that's correct. You add the standard deviation, 15 on each one. And then from the other side?
You subtract 15 from 100, so it's 85, and then 70 and the 55.
Yep. So you subtract 15, the standard deviation on your side. And then you see the arrow here. What percent falls into 1 standard deviation?
So that first one, like the total, wouldn't it be like, I think it was like 68.
Yes, this is 68%. 2 standard deviation. 95%. Yep. And 3 standard deviation.
99.7.
Yep. Now, can someone tell me what percent falls between 100 to 115?
34.
34%. And how you get 34 is half of 68. So this one is also 34%. What percent falls between 115 and 130? It will be 13.5. Does anyone know how to get 13.5? This is the same thing. And remember how I get 13.5?
Is that 95 divided by 4?
No, that's not right. It's 95 minus 68, and you divide by 2. 95, subtract 68, and the reason why you divide by 2, you got 2 of them. How about this one, the next one? This is 2.35%. Does anyone know how I get this 2.35%?
You take 100 and you subtract 99.
Not 100, not 100 yet.
99.7 minus 95 divided by 2.
99.7 minus 95 and divided by 2. You're correct. The last one. This is 0.15%. And how do I get this one? Casey? You take 100. Yep. 99.7 divided by 2. These percentages, 34, 13.5, 2.35, 0.15, they are all fixed. Same thing with 68, 95, 99.7. These are all fixed. You cannot change it. So how do we answer question 8? What percentage of IQ score are between 70 to 100? Now, I got students do this in the test. Oh, this one is normal. So I'm going to use my stack crunch, and I'm going to do the normal one. Remember, you did the normal one in the previous section. I will use my stats. I go to calculator. I go to normal. Oh, I know the mean. The mean is what? 100, right? The standard deviation is 15. And or this is between 70 to 100. So I put between 70 to 100. This is looks like it, right? Normal curve, mean is 100. Standard deviation is 15. And it's, you want to find between 70 to 100. This is what I did. This is what you did in chapter 6, right? Oh, this is my answer, 0.4772. Or if you write in percent, 47.72. And if you write this in your test, I will give you wrong.
I got 47.5.
The reason why you do this wrong is because this question does not want you to use your normal calculator. This question wants you to use this percentage. So you actually have to add 34 and 13.5. And that's why your answer in this case is 47.5. That's what Casey says. And again, class, if you don't give me percentages like this, I will also take points off. So make sure you have a percent next to it. You guys got what I'm saying here?
Yep.
Above 115. So 115 is this. Above is going this. So what do we need to add here?
13.5.
13.5.
0.35 and 0.15.
Yep. And don't forget, you can use, you know what, and make sure you put what percent symbol on it. And the last question is below 130. So this is 130 below, go down. So how you do this?
Can you take 100 and subtract the 0.15 and subtract the 2.35?
Yep, you can. That's the fastest way to do it. Or you add, right? You add all these numbers to the left, right? So they are the same. So this is 97%. You guys got what I'm trying to do here? 97.5, my bad. This is 97.5.
And you said that this one specifically, like, it never changes the, you know, the, okay.
Yep, all the rate, all the percentages, and it's never change.
Okay.
That's the meaning of normal curve. Questions? This is
so even if the mean and the standard deviation changes,
this is
it doesn't
change.
matter.
This
Okay.
will change. This will change. This is based on your mean and your standard deviation.
So
But-
those will change, but the other ones won't.
Yep.
The
The rest
percentages.
stays the same.
That makes sense. Thanks.
So this is how we do question number 13. So again, class, please make sure you practice this. I will see you guys on Wednesday at 4 o'clock in the classroom, and at 4 to 4:30 we will review. So we go over some binomial. We haven't done any binomial yet. So we do a little bit of binomials and a bit of normal distribution. And then at 4:30 you will take your midterms, and it ends at 6 o'clock. So make sure you have your computers with, bring your laptop. And I think you're allowed to use one piece of paper, right? To write all your formulas. Make sure it's one piece. front page, not both pages, just the front page. I don't care how big and how small you write, as long as you can. If you want to bring a telescope or reading glass or whatever you want, be my guest. I don't care how much. And if you want to type it out, you can also type it out. As long as it's one page, front page, how big, how small is up to you. Okay. And don't call me to read it because I'm not able to read your handwriting. Okay. I will say I don't know what you write. So I will see you guys on Wednesday. So if you guys have any questions, I will post this in in YouTube, and you can watch it again if you need to. If you have any questions, please stay back. If you don't have questions, you may go, and I will see you guys on Wednesday.